The weight percent of perchloric acid HClO4 in a concentrated perchloric acid solution is 60% by weight. Find the mass of 1 liter of the solution in gram. Then find the mass of perchloric acid HClO4 in 1 liter of the solution. Then find the molarity of the solution, and finally find the volume of the above concentrated HClO4 solution required to make 1 liter of 1 M HClO4 solution. Given the density of perchloric acid solution is 1.54 gram per ml. Let's start from part A. Part A asks to find the mass of 1 liter of the solution. Mass of 1 liter of the solution. 1 liter of the solution. So this is what we have to find. So volume is 1 liter. So we are given the volume of the solution is 1 liter. Okay. And we have to find the mass of the solution. Volume and mass are related by the density of the solution. So we will use the density of the solution to find the mass of the solution. Density of the solution is 1.54 gram per ml. So the conversion factor that we get from the density of the solution is 1.54 gram is equals to 1 ml. So since we are given 1 liter of the solution, we will start from 1 liter of the solution. 1 liter of the solution. Since the density is in gram per ml, density is in gram per ml, and we are given 1 liter of the solution. So first we have to convert 1 liter of the solution into ml or milliliters. For this purpose, we will use the conversion factor 1 liter is equals to 1000 ml. 1000 ml. So this is the conversion factor that we will use to convert the volume of the solution in liter to ml. Since we have to cancel liter and find ml, we have to keep 1 liter in the denominator and 1000 ml in the numerator. So now 1 liter will cancel out to give the volume in ml. Now we will use the density to find the mass of the solution. Since we have to cancel ml, we have to keep 1 ml in the denominator and 1.54 gram in the numerator. Now ml will cancel out to give the mass of the solution in gram. This gives us 1000 multiplied by 1.54 gram solution. This is equals to 1540 gram solution. So this is the answer for part A. So the mass of 1 liter of the solution is 1540 gram. Now let's move to part B. Part B asks to find the mass of HClO4 present in 1 liter of the solution. So mass of HClO4 present in 1 liter of the solution. So here HClO4 is the solute. So we have to find the mass of solute in 1 liter of the solution. In order to find the mass of solute, we will use the weight percent, because the weight percent relates the mass of solute and mass of solution. So we are given 60.0 weight percent of HClO4. HClO4. Weight percent HClO4 is equals to 60 gram of HClO4 per 100 gram solution. 100 gram solution. So 60 weight percent HClO4 is equals to 60 gram of HClO4 per 100 gram of the solution. This means that 100 gram of HClO4 solution contains 60 gram of HClO4, which is the solute. So this is the conversion factor that we will use to find mass of HClO4. From part A, we have already found that the mass of the solution is 1540 gram solution. This is the mass of the solution. Mass of 1 liter. 1 liter of the solution is the mass of 1 liter of the solution. 1 liter of the solution. So this is the conversion factor that we will use to find the mass of HClO4. We have grams of solution in numerator. So we have to put this 100 gram solution in denominator. So 100 gram solution. 100 gram solution. And we have to keep 60 gram HClO4 in numerator. 60 gram HClO4. Now, gram of solution will cancel out to give the mass of HClO4 in 1 liter solution. 1 liter solution. This will give us 1540 gram multiplied by 60 divided by 100. This is the gram of HClO4. HClO4 present in 1 liter of the solution. HClO4 per 1 liter solution. This gives us 924 gram HClO4. So this is the answer for part B. This is the answer for part B. Now let's move to part C. Part C asks to find the molarity of the solution. Part C asks to find the molarity of the solution. So now we have to find the molarity of the solution. molarity of the solution. Molarity is moles of solute per liter of solution. So we have already found in part B that 924 gram of the solute HClO4 is present per liter of solution. So we will use this 924 gram to find the molarity. Since we need the moles of solute, we have to divide 924 gram by the molar mass of HClO4 to get the moles of the solute. So what we got from part B is 924 gram HClO4, 924 gram solute per liter of solution. So now we have to convert this grams of solute or grams of HClO4 into moles of solute. Molar mass 100.46 gram is equals to 1 mole. So this is the conversion factor that we will use to convert grams of HClO4 into mole. Since we have to cancel grams of HClO4, we have to keep 100.46 gram in numerator, HClO4 in numerator, and 1 mole HClO4 in denominator. Now grams of HClO4 will cancel out to give moles of HClO4 per liter of the solution. This gives us 924 divided by 100.46 mole HClO4 per liter solution. This equals to 9.20 mole per liter or 9.20 m. So this is the molarity of the solution. This is the answer for part C. Now let's move to part D. Part D asks to find the volume of the above concentrated HClO4 solution required to make 1 liter of 1 m HClO4 solution. So the molarity of the concentrated HClO4 solution that we got from part C is 9.20 m. This is the molarity of the concentrated HClO4 solution. Now we want 1 liter of 1 m HClO4 solution. Since the molarity is smaller, we have to dilute this concentrated HClO4 solution to get 1 m HClO4 dilute solution. So This question is related to dilution. So in part D, we have two different situations. One is before dilution, and another is after dilution. So before dilution, we have concentration C1 is equals to 9.20 m, because before dilution is the concentrated HClO4 solution, and V1 is what we have to find out. This is what we have to calculate. And after dilution, after adding water, we get C2 equals to 1.000 m HClO4 solution, and volume V2 is equals to 1.000 m. Volume is V2 is equals to 1.000 liter. Since we only have added water, the moles of HClO4 remain same before and after dilution. So moles of HClO4 before dilution, is equals to moles of HClO4 after dilution. We calculate the moles of a solution using the formula concentration multiplied by the volume. So moles of solution before dilution is C1 multiplied by V1, and the moles of solution after dilution is C2 multiplied by V2. Now we will put the given values into this equation. This implies C1 is 9.20 m multiplied by V1 is equals to C2 is 1.000 m multiplied by 1 liter. Since we have to find V1, we have to divide both sides by 9.20 m. So that this 9.20 m will cancel out to give V1. This implies V1 is equals to 1 multiplied by 1 is equals to 1 divided by 9.20. This m will also cancel out to give liter, 1 by 9.20 liter, and this equals to 0.1087 liter. So this is the volume of concentrated HClO4 solution that we need. Now we have to convert this into ml by using conversion factor. 1 liter is equals to 1000 ml. The 1 liter will cancel out to give 108.7 ml. So this is the final answer for part D. So we need 108.7 ml of concentrated HClO4 solution to prepare 1 liter of 1 m dilute HClO4 solution. You are done with all parts.